Okay, can you guys see my screen? Okay, let's start the practical session. Uh, I'm TA Yansu-won, and today's session is about word-to-back. Today we will cover implementation of word-to-back, especially SkipGram. Starting from tokenizer, we will build vocabulary, and we will implement SkipGram and SkipGram with negative sampling. In the next session, we will use some sentence-based library, and we will learn how to use sentence-based package, and we will visualize the result. Similar to the other practical session, feel free to ask me, and if you have any question, this is my email, and feel free to ask anything about this practical session with my email. Okay, let's start from word-to-back. In this session, we will implement word-to-back from very basic function building block. First, import the Python library, which we will use in this session. Just run this code. Okay, and implement the tokenizer. In this session, we will implement very basic tokenizer. We will call this white space tokenizer. It requires only two functionality. First one is break the sentence into the words whenever it encounters a white space character, return the list of words. So this means that if the sentence is I am a student, the result will be I am a student. This is the result of white space tokenizer. And next requirement is for punctuation marks should be independent tokens. So the punctuation marks are here, period, comma, exclamation mark, and question mark. And they should be tokenized into independent token. So this is the only requirement for the tokenizer. I will give you 5 minutes to implement this tokenizer here. So you implement the tokenizer code and test the tokenizer is right well. If the code is implemented, the output will be test passed. So first, I will give you 5 minutes, implement this function and test your function. I will give you 5 minutes. Okay, I will show you solutions. I think everyone might do well. Okay. First, I will use the Regx. So the Regx is Python for use Regx in Python. We have to import re, and I want to spell the sentence like re.soft. This is do the same thing with Python library native function like replace. So this might be like, and I will replace first 4 punctuation marks with the white space on the left and the right side. So, okay. Okay. Thank you. Sentence. So, like this, and do period and comma and exclamation mark and question mark. And then I will split the sentence. Tokens equals sentence dot built. So it's simple way to do. So I will test my tokenizer function. Yeah. So it works well, and I'll move to the next part. Next part is the building the vocabulary. So in this session, we will build the vocabulary for further use. I write some requirements for the build function. The input arguments will be sentence and mean freak. Sentence is the list of sentence to build vocabulary, and each sentence is list of the word, and mean freak is the okay and okay mean freak is the minimum frequency of the word, and words that have frequency less than threshold are excluded from a vocabulary. So this is because we want to try to handle rare words which occur generalization issue, and we return the 3 dictionary, IDX to word and word to IDX and word freak. First, IDX to word is dictionary that maps index to the words. So, and word to index is dictionary that maps word into index. Okay, I will show you the codes a bit more. Okay. Can you copy the past code, copy past code here? Yeah. Okay. I'll wait a second. This is the code for the tokenizer. And last words freak is the frequency of the word. And you can check the key and value in here. Okay. And so this is the input and this is the output. Remember the input and output and implement the build vocabulary. I will give you 5 minutes. And after 5 minutes, let's check together how to implement the build vocab. Before check the solution with me, if you implement all the build vocab, you have to run this test function to check your code is right. Okay, I will give you 5 minutes to implement this code. Okay, I will show you the solution. First, For concat all the lists of the word into the single list, I will concat like make button or the for the single asterisk means that passes the elements of the sentence to the function of the chain, and there have like this double asterisk. It means if the sentence is the dictionary, then it passes arguments as the names becomes a key and value becomes a dictionary. And for this, I will use single asterisk. If you want to more information about this one, see the document, and I will make a count dictionary. So I will use counter, which is collection library. So counter button. So and let's build the vocabulary. So iterate all the word frequency. So word. And I will filter the rare one which occur the generalization problem if the freq is more than min freq. So I will filter out less than the word frequency. So I will write the code like this. So if so if I will add the dictionary like this, then rare word. Oh, thank you. Word. Right? Or else I will pop like this word and add the number of free and add the unknown token to the word frequency. So like equal there freak thing. Yeah. I will sentence is not defined. Sentences. Wait. Sentences here. Okay. Items. freaking word copy that. Uh, this is pop the word which is not which is this is pop is if the word is not in the dictionary, we will pop the word. This is pop is out of the word, out of the dictionary. Yeah. So yeah, this is the code for the build vocab function. And I will test the vocab, build vocab function. It works well. And okay. Let's do the SkipGram. So in this section, we will implement the SkipGram. We also prepare it's like, yeah. Okay. Okay. So we prepare the input for training word back. As you see in this code block, we will return the tuple that center words and the surrounding word pair was SkipGram. So I will explain more about the function and the exam. The function receives two input arguments, tokens and the window size. Window size is the number of the neighbor. So as you see in the figure, the example of window size is 3, and this is the center word. And the center word includes the neighbor with the distance, the 3 in both sides. So if I will show the before I there is a question. Should the token UNK be part of WordFreak? Yeah, because yeah, this is, as you see here, this is unknown token for, yeah, we use like this one. So yeah, move on to SkipGram, and I'll explain the SkipGram with the example. There is like sentence like John's book is not popular. If the center and the window size is 2, first the center word is John's and the window size is 2, so the first tuple gonna be like John's and book and John's and is. And next we will move the next center word with book, and it consider the two skip window with the both side left and right. So book and John's and books and is and books and not is one of the pair of the tuples, and doing the same things like it. So this is, we will input the tokens and the window size. The window size is 4, and the return must be the window pairs, the list of the tuple. Tuple is the surrounding word, center word and surrounding word. So I will give you 5 minutes and implement this function. And after 5 minutes, let's check the solution together. Okay, I will give you 5 minutes. Can you show the last code again? Okay. This is the build vocab code. For build vocab code, you can see the screen and follow the code like this. It really works properly. It seems just yeah. Yeah, it pretty works well. Okay, I will check again. Mm. 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 Oh, yeah. Okay, maybe this is not clear, so I will change the code and upload with custom another solution. So, okay, and then let's do this get window pairs. And so I will let's implement together for and start equal first calculate start like this. Start should be the minimum 0 to index minus min size, right? And this mean when token min size plus 1. Like this. And or sliding from start to end. So here. Okay, so and then start will okay, maybe this one, and you will see when you test it works like this. Okay, so okay, next this one, prepare the data set. In this section, we will implement the negative sampling function to improve SkipGram. Before to move SkipGram, and in this session, we will implement negative sampling function to improve SkipGram. Here is the negative function. Should be sampling the word from this probability distribution. And your job is to prepare the negative sample function, and input arguments is the power, which is 4.75 in this figure. And this part is and word and the word frequency is a dictionary implement above we implement. And okay, so your job is to make the negative sample table. It does not actual the return of output, so I will give you 7 minutes to implement this negative function. And let's see, after 7 minutes, let's see the solution together. Okay, I will give you 7 minutes to start implement this code. Okay, I will show you the window code. No pairs. I will show you here. And I think else is. Uh, for build vocab, I think you have to change this like this. And uh, it's just functions post. Um, um, I don't know what you mean. The question is exactly the question's meaning. Okay, let's check together before check the function. The else, I have a mistake, like else is like this. And and let's implement the negative sampler. Before check the negative sampler, first let's check this function together. Uh, um, um, yeah, upper. Uh, I think not. Yeah. So in the SkipGram dataset class, there is pet token and pet token index and unknown token and unknown token index. And we initialize with the document, window size, main freq, negative sampling, false. Document is the list of sentence, and the window size is window size. Yeah, and so we will first tokenize into the words and collect the tokens in here. And we also apply to build the vocab function to the token index word, index to word, and word to index, and word freq. So we assume index to word to index to word, underbar index to word, and word to index to underbar word to index, and we assume word to freq to underbar word to freq. So, and we do negative sampling. So we construct word to index we will construct negative sampling table and then prepare some items in there, like, and we prepare the data set for the training. So let's do this. Let's implement the code. First, the booklet size should be the length of the word freak, because the word freak dictionary contain all words here. So freak, and the power is in this figure. This is 0.75, and normalizing constraint norm is, this is counter words appearance in the word corpus. This is same as this one in the figure. So messed up. Count comma power. That's the power. Yeah. Okay. And the table size is the length of unigram table, and we define the table, and table size is arbitrary large number. So I will write like this. But if you want to change, you can feel free to write another large numbers. And yeah, like this. And add some element for table array. We do like p equals 0 and I equals 0, and temps and p my power, and divided by norm, and we instantly terminate. We do the while loop, or the like this. So table self dot. Okay, we do this all the words in the table until the table will be the fields with the word index. So sampling the word from the probability like this, and finally we will get self dot negative sampling negative sample table equal table. Okay, so we assigned the table to the negative sample table, and we do this, all the words in the tables will be the field with word index, and sampling the word from the probability that you see in the figure. And so this is the code for the random sampling from negative sample table. I believe you can just implement the negative sampler by mp.random, and the probability distribution follows like this figure. And if we do the negative sampling, the output would be the center words and the surrounding words plus negative sample with number of k. Okay. So this is the sample document there, and please run the code like code this one. RAM so test this one. Okay. Okay. Next part is training the SkipGram without negative sampling. In this section, we will implement object function in the SkipGram, and the object function is the softmax over center word and surrounding words. I think everybody learned it from that section, so I will give time to fill this code here. After 5 minutes, let's check together. Okay, for this one, let's see together. So this was a solution, and for time issue, I will explain with the solution code. First, the input feature is a tuple of the center words in center word indices and surrounding word indices. And so split input feature into input index and target index. And before mapping the input indices, we do the embedding like this. Mapping into indices to the latent space, which wizard the input embed, and obtain the logic with the matrix, multiply with input embed, and self.output embedding. And the loss will be the cross entropy, and we calculate the loss with logic and target IDX. Everyone follow like this. And the negative sampling code is very similar with this one. So I will explain with the solution code. So I think everyone can follow this very easily because it is the same as the code we implemented both. So this is the different thing because for the negative sampling, we have to consider the negative sample indices. So the shape would be the batch size dot comma k. So it is the different thing. So the result batch by the number of negative words, that's a different thing from the above code. And the other part is same with the codes we implement above. And the logic and apply the all zero as the label and calculate the cross entropy in here. So this is the loss function. And then let's do the sentence piece and word back. I will introduce this one very briefly because it's very basic library, and nowadays people do not use word to back this sentence piece, and nowadays many people use Hugging Face tokenizer. So, but in today's session, we will study the sentence piece tokenizer. Before use, please install this one, set up the code, and install the NLTK and download the data set. And we have to implement all the required package. This is the word-to-back. Jensen provide the word-to-back function, and this is similar work that we define in the part 1. So, but I recommend you to use this one because it's very easy to use word-to-back as package. And for, yeah. And this is setup parameters. This is dimension of input features and number of negative sample and how to handle this one is minimum. This one is minimum words in one sentence, and how to this means how to handle the rare words. So the token which appear less than 10 times we assume as unknown token, and window size is 5, And downsampling is 0.75. This is same as the power equation in negative sampling, and it approaches 5. So, and let's prepare the data set like this. Put the data sets into the list like this. And then filtering them with split, put token in the sentence native. And then this text txt contain the post train and negative train. So this is contain all the text file, and vocab size is the number of the subword. So feel free to run this code. I think for training, we have to wait a long time. So I did not train in this practical session. So after practical session, you have to run the training code and see the visualize with his knee. And I will just explain. This is the training with the word to back. And yeah. Right. I think for this training, it takes like 3 minutes. So for CPU times. And by this, I will see you the output. With this, we will see the most similar word with men. So like boy, woman, person, guy, teenager comes like this, which is similar to the man. And by this code, you can see the key to index, which is contain the word back. And use this, we can see the top and similarity by vector functions with king minus man plus queen by use this code. And then we can visualize the tokens like in here. This is the center word, so you can see this you can see well, but when you run this code, you can see the subword code, but subword code can not see easily because subword do not contain the meaning. So it may be hard to capture the code. So I recommend you to training and see the results of this visualization result after this class, and I will end the class from here. So if you do not have any question, you can go out from the lecture. 실습은 여기서 끝내겠습니다. 혹시 질문이 없으시다면 나가셔도 좋습니다.